In the near future, I'll be needing several tools, in particular a table saw. Of course, I could just buy one, but where's the fun in that? Instead, I'll do it DIY style. I've studied a couple of videos, and the general approach seems to be you take some old handsaw, screw it to a board of plywood, and voila, you're done. Since the machine becomes inaccessible in such a configuration, an alternative switching mechanism is needed. Many people solve this problem using this, which I don't find very attractive. A simple button would certainly serve the purpose, but you never know what happens with self-made machinery. I want to be able to cut power quickly if something starts screwing up. So, it's still experimental, and it remains to be seen whether or not it will prove practical, but here's what I came up with. The device incorporates three inputs: a start button, a foot pedal, which will act as a deadman switch, and an emergency kill switch. The start button and the pedal are connected to the electronics box, which will handle all the 5-volt electronics and logic stuff. It will also receive a 5-volt DC power supply. The little numbers, by the way, represent how many wires are needed for a particular connection, so usually it's going to be 2. The output is connected to the relay box, which handles the main 240-volt AC power supply. You can see this connection has 3 wires because it comes with your standard protective earth, which I will send to the rest of the system. Because the current has to go through the kill switch and the contacts are exposed, I'll have to integrate it into the box, so this connection will be inside of it. Finally, the output is connected to one final box, which will basically be a regular power socket. All modules are going to be designed independently, so I can recombine them if I need to. The functional principle is best explained with a table showing the conditions that I want to implement. The most obvious one is that when the kill switch is activated, the output should be dead. Easily done by connecting it in series with the main power supply. Furthermore, to cover the deadman switch aspect of the whole thing, whenever the pedal is released, the output must be dead as well. The next two conditions make sure that the output is not switched on by accidentally hitting the pedal or the button. So how do we activate the output? First of all, the kill switch must be off. When the pedal is pressed, the start button becomes available. As the start button is pushed while the pedal is active, the output is activated and remains active as long as the foot stays on the pedal. The start button can be released at this point. The conditions are implemented like this. The foot pedal is connected to an AND gate which triggers a relay. The relay controls the main power supply. This handles condition 2 because no matter what, if the pedal is released, the gate turns off. The second input of the AND gate is connected to an OR gate. Here one of the inputs is the start button and the other is the AND gate's output in a feedback loop. Conditions 3 and 4 are true because neither start button nor foot pedal can turn on the relay alone. Only when both are pushed simultaneously will the relay turn on and trigger the OR gate's other input so that the start button can be released. This behavior covers conditions 5 and 6. This, of course, is a simplified illustration, so let's take a look at the actual soldering template. The whole circuitry will be realized on a universal PCB. The one I'll use is 28 by 18 holes, which should be plenty of room. The main interface to the outside world will be a 5-pin header strip sitting in the corner. The associated rows will be used in a bus-like manner, meaning that when I design the rest of the board, I'll assume certain horizontal lines like these to be connected all the way through. From top to bottom, the pins will be 5-volt input, ground, foot pedal, start button, and the relay. For the logic gates, I'll use the 08 and 32 of the 74HC chip family. Each chip contains 4 independent gates, but I'll only need 1 gate per chip. The chips are placed at the bottom with at least 1 row of holes as margin. Both are connected to 5-volt and ground. The gray line indicates a solder connection. As explained earlier, the pedal input is connected to the AND gate, while the start button is connected to the OR gate. The two connections between the gates are done horizontally, the OR gate's output to the AND gate and the AND gate's output to the OR gate. Because the chip's output current isn't big enough to trigger the relay, a transistor is needed. I'll use an open drain configuration with room for base resistor and a flyback diode. The AND gate output is connected to the base over a 1K resistor. When the output is high, it will turn the transistor on. The current will flow from the relay through the resistor into ground. To avoid damage due to inductive voltage spikes from the coil in the relay, a flyback diode is used to send excess current back to the 5-volt terminal. Because the gates don't have internal resistors, the input for the pedal and start button need to be pulled down to ground whenever the switches are open. Finally, the missing horizontal connections are inserted or soldered together when there isn't enough room for a wire. And this is what the board looks like now that I'm done with the soldering and all components in place. As you can see, I haven't soldered the components directly to the board. That is because I wasn't sure how things would turn out, and I wanted to have the option to replace the key components without much trouble. For that I used these socket pins. I also put a drop of hot glue on each component to ensure that nothing falls out due to vibrations. For the housing of the electronics box, I'll use this plastic one that I salvaged from a recent dumpster dive. They aren't terribly sturdy, but they have the right size and it's all I've got at the moment. I want the board to sit in the middle, somewhere like this. To keep the electronics safely away from the housing, I'm going to use these spacers. A hole at the bottom will let all the wires out. The internals of the box are going to look like this. The positive terminal of the DC power supply is going to be distributed to the board, the foot pedal, the start button, and the relay. For that, I'll use this 5-slot junction. The returning wires from the pedal, start button, and relay are going to be connected to the board as described earlier. Finally, ground is connected to the second pin of the board. To make sure the cables don't slide out of the box, I'll use these scrap pieces of foamy plastic to sandwich them in place. During assembly, I noticed that the screws of the cable holder get dangerously close to the circuit board, so I decided to drill another hole at the side. Doesn't make the whole thing prettier, but I think it's more comfortable that way. Before putting everything together, I want to make sure the electronics work as expected. The relay box isn't ready yet, so I connected the relay directly. The foot pedal isn't ready either, so I'll short the connector for the start button and use the start button as the pedal. In other words, if I press this, the relay should turn on. You should be able to hear the clicking sound from the relay. You can even see the LED flashing due to the inductance of the relay's coil. I do have actual diodes that I could use, but I think I'm going to leave it in there. It's a good indicator that everything works.